card is selected at random from a standard 52 card deck. Now, before we answer parts A, B, and C about this question, a 52 card deck, we've got spades, we've got clubs, we have hearts, and we have diamonds. Okay, and I put them in colors on purpose because if you don't play cards, spades and clubs have black numbers and hearts and diamonds are red. Now, all four of these go from ace, 2, 3, all the way up 10, and then jack, queen, and king. So there are 13 values of each one, if you count them. Okay, so when they talk about, there are 13 spades, 13 clubs, 13 hearts, and 13 diamonds. So if you're talking about just kings, right, there are 4 kings, because there's a king of spades, a king of clubs, a king of hearts, and a king of diamonds. So that's something to keep in mind when you're playing with cards in terms of probability. Part A. What is the probability of selecting a diamond? Well, there's 2 ways to think of this problem. First of all, a diamond is one of the suits, and there are 4 suits. So a diamond is 1 out of 4, right? Okay, you could also write that as a decimal, 0.25. But you could also think, well, out of 52 cards, right, 13 of them are diamonds. So 13 out of 52, of course, if you reduce that, you get 1/4. Either way, 1/4 is your answer. What about the probability of selecting a jack? Well, remember, we've got the jack of spades, the jack of clubs, the jack of hearts, and the jack of diamonds. So there are 4 jacks out of 52 total cards. Reduce that, and we have 1 out of 13. Now, of course, if you need to change this to a decimal, you're going to have to do that and round accordingly. And the last one, what is the probability of selecting a jack or a diamond? Now, the key word here is or. Or means to add and subtract the overlap. I'm a big fan of writing it out in words first because then I can see exactly what I'm looking for. So I want the probability of a jack plus the probability of a diamond, right, because it says jack or a diamond. And then I'm going to subtract the overlap, which is a jack of diamonds, right? I put them together. So this last one is the 2 first pieces put together, jack of diamonds. Okay, so the probability of selecting a jack, we found that at the very beginning. Nope, that's the wrong button. The probability of getting, there are 4 jacks out of 52 cards. Well, there are 13 diamonds out of 52 cards, and there is only 1 jack of diamonds. The reason we have to subtract the overlap is because you counted the jack of diamonds twice, right? We counted it as a jack, and then we counted it again as a diamond. You can't, the card is only in there 1 time. So the subtraction allows you to not count it twice, basically. So now in our fractions, right, my denominator is the same, so I have 52 in the denominator. So 4 plus 13 is 17. 17 minus 1 is 16. So I end up with a probability of 16 over 52. Both top and bottom are reducible by 4, and I end up with 4/13 as the probability of selecting a jack or a diamond.